Today's video is on multiplication properties of exponents. So it's basically we've got exponents going on and we have multiplication going on. So what do we do with the exponents in these situations? All right, so there are three different properties we're going to learn in this video. The first one is called the product of powers. So here's an example: x to the third times x to the fourth. So here is a product of two powers. Okay, so this is my little slogan that you're going to hear a lot. This unit, when in doubt, write it out. So this is going to the basics of what does an exponent even mean. X to the third means x times x times x. And then I'm multiplying by x to the fourth, which means x times x times x times x. So now, this is all really just multiplication in between. So how many x's do we have? 1, 2, 3, 4, 5, 6, 7. So this becomes x to the 7th. All right, next example. So this time I'm going to have some coefficients. 4x squared times 5x to the 6th. All right, so my powers are where my variables. So the exponents only apply to the variables, and then the coefficients, are kind of like separate. Now, it's all multiplication throughout. So you can multiply in any order. So I'm going to rewrite this as 4 times 5 times x squared means x times x, and x to the 6th means 1, 2, 3, 4, 5, 6 x's. So my coefficients, I can just multiply. So that's 20, and then how many total x's are there? 1, 2, 3, 4, 5, 6, 7, 8. So x to the 8th. And then third example, so I have a squared b to the third, and I'm multiplying by a b to the 5th. All right, so this looks slightly different, but really all this is, with all these parentheses and everything, it's just a bunch of multiplication. So a squared simply means a times a. And then over here I also have an a. And then b to the third means b times b times b. And b to the 5th means b times b times b times b times b. So I can multiply in any order, so I like to just rearrange them so they're grouped together. And then you're just counting how many of each do you have. So this would be a to the third, and then this becomes, whoopsies, b to the 8th. A to the third, b to the 8th. All right, so what I want you to notice, so 3 and 4, when you're multiplying, what do you actually do? Add the exponent. Here, so the coefficients, we multiplied normal, but your exponents, 2 and 6, we add to 8. Here's a 2. This technically has exponent 1, goes to 3, and then 3 and 5 go to 8. So the rule to remember for the first property is you're adding exponents. When you are multiplying powers with the same base, x to the m times x to the n, same base, powers, we're multiplying, it equals x to the power of m plus n. So now, 3 quick examples without writing it all out. All right, so if you are multiplying these two powers, x to the 12th times x to the 27th, all you have to do is add your exponents instead of writing it all out. So this becomes x to the power of 12 plus 27 is 39. All right, so here, a reminder, your coefficients are not powers. And then this is all just multiplication, and I can multiply in any order. So if I rewrite this as 2 times 7 times y to the 7th times y squared, 2 times 7 is just 14, and then you apply your property of exponents to your exponents, which is to add them, so y to the 9th. Alright, and then this last one. So we have parentheses, but it's really no different than this example here. Just looks slightly different with the parentheses. It still is all just a bunch of multiplication. So -5 times 9 times a to the 3rd times a to the 14th is really another way to write that exact equation. Coefficients, you multiply like normal, -45. Apply the property to your exponents, 3 plus 14, so it's a to the 17th. And that is it. Alright, the next property is power of a power. So what this looks like is, if you have a power, so I have 2 squared, and I'm raising that power to another power. 2 squared to the 3rd. So what that means is, so this exponent 3 tells you that you have 3 of those. So if I do the when in doubt, write it out, so that means I have 2 squared 3 times. And then for each 2 squared, that's 2 times 2. 2 times 2. 2 times 2. Boom, boom. So how many 2's are there? 1, 2, 3, 4, 5, 6. So this becomes 2 to the power of 6, which you can then evaluate all the way, which is 64. Alright, so now something with variables. So let's say I have x to the 3rd to the 4th. This 4 tells me there's 4 of these. So that means x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. 4x to the 3rds, and then each x to the 3rd means x times x times x. So I have 4 sets of 3, so now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This becomes x to the power of 12. Alright, and then if I have x to the 5th squared, so once again, the exponent tells me I have 2 of those. So x to the 5th times x to the 5th. What that means is 1, 2, 3, 4, 5. Boom. 1, 2, 3, 4, 5. How many total x's? X to the 10th. So if you haven't noticed already, let's look at the exponents. What's the pattern here? 2 and 3 gave me exponent 6. 3 and 4 gave me exponent 12. 5 and 2 gave me exponent 10. So the rule to remember for this property is to multiply your exponents. If you have a power, x to the m, and you raise it to another power, it is equal to x to the power of m times n. So here are 3 examples. X to the 8th raised to the 9th. You just multiply 8 times 9, so this becomes x to the power of 72. Alright, y to the power of 3, and then raise that to the power of -2. Multiply here. So this becomes y to the power of -6. But remember, don't leave a negative exponent in your final answer. So this goes one step further to be 1 over y to the power of 6. And then the last one, I definitely wouldn't want to write this one all the way out, because all you have to do, multiply your exponents. 32 times 4, this becomes a to the power of 128. Alright, here's the last property of this lesson, and this is power of a product. So you're starting with a product and you're raising the product to a power. So what that looks like would be here, 3x squared to the power of 3. So here's my product, raising it to a power. So the exponent on the outside, that tells me I have 3 of these. So that means I have 3x squared times 3x squared times 3x squared. Now, the exponent is only applying to the x, not to the 3. So if I'm going to rearrange this, I have 3 times 3 times 3, and then each x squared would be 2 x's. So 3 times 3 times 3, that is 27, and then count your x's, that is x to the power of 6. All right, next one, -2 y to the 4th, and then that squared. So this exponent tells me 2 of those. So -2y to the 4th times -2y to the 4th. Alright, so remember the exponent only applies to the variable, so I have a -2 times a -2. And then 1, 2, 3, 4 times 1, 2, 3, 4. Alright, so that becomes -2 times -2 is a positive 4. Count your y's, that becomes y to the 8th. Alright, given my room, a little bit more room for this last one. So if I have x squared, y to the 3rd, z to the 4th, all of that to the 3rd. So that means I have this 3 tells me I have this 3 times. So x squared, y 3, z 4, boom. X squared, y 3, z 4, boom. X squared, y 3, z 4. And if I expand that all the way, so I have x squared, x times x, this x times x, and this x times x. Look at my y's, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm going to run out of room for my z's, but that's okay, I'll go underneath. So that's 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So how many total do I have? I have x to the 6th, I have y to the 9th, and z to the 12th. Alright, so what exactly is happening here? It's really just like power to a power here. I've got this 3, but it's kind of being distributed to each one, to every part of the product. So 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. One thing that you do have to be careful of is when you are kind of distributing the exponent to a coefficient, you raise the coefficient to that power, but you multiply the exponents. Make sure you're not multiplying to the coefficient. You have to treat that like a normal number, -2 squared, and then multiply your exponents. So with this property, so it's not the distributor property, it's not technically the correct word, but it's the best word I can think of to explain what we're doing. So if you have a product, so let's say a times x to the power of m, and you're raising the product to the power of n, it's like you're taking the exponent and making sure it's distributed to everything inside parentheses. So this would be your coefficient a, you have to raise it to the power n, and then, whoopsies, and then times x to the power of m times n. Alright, here are 3 examples. Instead of writing it all out, we're going to apply that property. Alright, so the first one, the 3 on the outside, think that you are distributing to everything inside parentheses. So this becomes the coefficient 5 to the power of 3. And then x, when you have two exponents, you multiply x to the 12th. Now 5 to the third power is 125. So 125 x to the power of 12. Alright, so next one here. Same thing, exponent on the outside needs to go to everything inside parentheses. So this becomes a negative 3 raised to the power of 4. And then x, multiply your exponents 2 and 4, x to the 8th. And then the y, it doesn't have an exponent, which technically that means it's exponent 1. So 1 times 4 is 4. And then finish evaluating this. Negative 3 inside parentheses raised to the even power of 4. So that's a positive 81, x to the 8th, y to the 4th. Alright, and then the last example. Alright, distributing a negative exponent. So coefficient negative 2 in parentheses to the power of negative 2. X, negative 2 times negative 2, that goes to a positive 4. And then 3 times negative 2, y to the power of negative 6. Alright, we have to deal with those negative exponents though. So x to the 4th is a positive exponent. It stays. The other ones get kicked to the basement. They go to the denominator. So x to the 4th over, so y to the power of positive 6, and then negative 2 to the power of positive 2, and then that turns into a positive 4. So I'm just going to erase that, and we can just change it to 4. And there is my final answer. And that is 3 properties of exponents, all involving multiplication. Good luck with the assignment.